So this is the last module for our chapter, first chapter, number systems. In this chapter we will be dealing about the laws of exponents. Now dear children, you have already learned the laws of exponents in your grade 8, but in this chapter the most important law which we are going to see is that, you can see on your screens also, nth root of a. It's very important. Nth root of a would be a raised to 1 upon n. That becomes the fraction. This becomes the fractional power of a. You know that exponents means what? Powers. And this nth root over here means the fraction 1 upon n for a. So as you can see, if it was cube root of 2 means 2 raised to 1 upon 3. Okay, if it was fifth root of 2, it would have been 2 raised to 1 upon 5. Seventh root of 3, 3 raised to 1 upon 7, and so on. This means 1 upon. This means 1 upon. And now, see, you will understand one more thing. So, this square root 4 means what? Nothing means 1 upon 2, or what? Root means 1 upon 2. So, it would have been what? 4 raised to 1 upon 2. Clear? And now, you know that what is 4? 4 could be written as 2 square. And 2 square raised to 1 upon 2. You're going to learn this, but see what happens. A raised to m raised to n. It would become a raised to m raised to n. And this 2 upon 2 gets cancelled. 2 raised to 1, which is 2. You know that root 4 was 2. So that is a way. But square root means raised to 1 upon 2. Cube root means raised to 1 upon 3. Nth root means raised to 1 upon n. That is very, very important. And using this very law and our other laws, which you can see right now on your screen, very, very simple laws. A raised to m into a raised to n. You know that it was a raised to m plus n. A raised to m divided by a raised to n. You know that it was a raised to m minus n. A raised to m whole raised to n. You knew that it was a raised to mn. A raised to m multiplied by b raised to m. You knew that. See here very carefully, if the powers are same, you could combine the bases. A b raised to m, and our very important a raised to 0 is equal to 1. So what we are going to do is that very, very quickly we will be using these laws to get the answers for a few of our sums, and the remaining sums using the same strategy, same rules, laws of exponents. You can very easily solve the remaining sums. So what you can see here now, we can see here is that we will take few examples from our exercise. Very easy. What you are going to do is that, children, these bases, you will try to express them in terms of exponents. 32, prime factorization, what it is? 2 raised to power 5. You check it out. You prime factorize 32. 2, 16, 2, 8, 2, 4, 2, 2 and 2, 1. 1, 2, 3, 4 and 5. So 2 raised to 5. 2 taken 5 times. So this was what actually? 2 raised to 5 raised to 1 upon 5. And you know that a raised to m raised to n is a raised to mn. So using, I can write over here using a raised to m raised to n is a raised to mn. What are you going to get? 2 raised to 5 into 1 upon 5. And 5 into 1 upon 5 is just 1. 2 raised to 1, that is 2. Correct? Very easy. Very easy you can apply these laws of exponents. Simple sums it is. Next sum what you can see is 9 raised to 3 upon 2. Let me check 9 raised to 3 upon 2. How can you write 9 as? 9 could be written as 3 square. We know that 9 is a square of 3. So I am just writing 9 as 3 square raised to 3 upon 2. Again, a raised to m raised to n, a raised to mn. So 3 raised to 2 into 3 upon 2. 2 and 2 gets cancelled. 3 raised to 3, 27 comes out to be the answer. It is going to be simple and straightforward. What we can see now, the next example. Very quickly I am taking the example, children. You can write it down and then you can solve it on your own. Just applying your own logics behind that. Again, 16 raised to 3 upon 4. Now, what you can see, 16 you know, it's either 4 square. 16 could also be 2 raised to 4. See what? 2 2s are 4, 4 2s are 8, 8 2s are 16. So I can either write 2 raised to 4 because raised to 4 and upon 4 is going to get cancelled. Or suppose in the exams I don't remember. I remember 16 as 4 square. Simple. Let me do it like that also. 4 square raised to 3 upon 4. So 4 raised to 2 into 3 upon 4. So 2 ones are and 2 twos are. 4 raised to 3 upon 2. 4 could also be 2 square raised to 3 upon 2. 4 is nothing but 2 square. Again 2 and 2 gets cancelled. 2 cube, that is 8. Or else, if you could have remembered, 2 raised to 4 raised to 3 upon, because 16 is 2 raised to 4. So 2 raised to 4 into 3 upon 4. Again 4 and 4 cancels. 2 cube, that is equal to 8. Very simple. We are going to apply the laws of exponents. The next example what we are going to see, again it's a simple example. You can see on your screens right now. The next example what it could be, you can see, tell me which law are we going to use? What is this? This is A, M, again A, N. A raised to M into A raised to N is A raised to M plus N. It will be what? 2 raised to 2 upon 3 plus 1 upon 5. Correct? And now just here we'll solve the fraction. How do we solve the fractions? Either we cross multiply or make the denominator same. LCM, any way you can do. I would prefer here cross multiplication. So 2 raised to 2 into 5 plus 1 into 3 upon 3 into, say this, cross multiply. 5 goes to 2, 3 goes to 1, and these two get multiplied. So it becomes 2 raised to 5 2s are 10, 3 1s are 3, 5 3s are 15, 2 raised to 13 upon 15. So likewise, children, we can use a simple laws of exponents. But remember, whenever there are some bigger, higher numbers, see 32, you will write it as 2 raised to 5. 64 is either 2 raised to 6 or 8 square or 4 cube, anything, whichever suits the situation. 125, yes, it is 5 cube. So cube root of 125 would be 5 because raised to 3 raised to 1 upon 3. So that's all. That's the last part of our chapter. Applying the laws of exponents for real numbers. Correct? So that's all from my side. Have a nice time. We'll be solving the exercise questions. Thank you.